So to finish this chapter, I just wanted to make a small summary with a nice little slide and animation to just summarize what we just discussed in those two parts, and especially in this part 2 of this chapter. So again, for an organism to be able to live, you need a source of carbon, a source of energy, also a reducing power. You can also simplify that by saying a source of electron. The main carbon cycling is dealing with the cycling of carbon between the most oxidized form of carbon, which is CO2, and the reduced form of carbon, which is organic carbon. The most reduced form of carbon will be methane in our case. The more widespread or known reduced form of carbon is methane. You understand that the first metabolism is to be able to reduce this oxidized form of carbon, which is CO2, which is in abundance, even if it's in trace in the environment, it is highly soluble in water. We have seen that. You can find a lot of CO2 in the atmosphere, inside the water. That can actually be fixed through photosynthesis. And to do that, you need an electron donor because you need to reduce this CO2. And so this electron donor in oxygenic photosynthesis is water. Water will give the electron that will be excited because you need more energy. Those electrons do not have enough energy to oxidize CO2. So you need to have a photosystem to grab the photon from the light to excite those electrons to be able to reduce those CO2 into organic carbon. So this photosynthesis is a fixation of CO2 through redox reaction and piling energy from the sun into the organic carbon. Of course, photosynthesis has a positive delta G, so need energy to do that. So then, when you have this reduced form of carbon, you can have the reversed reaction, which is aerobic respiration, using oxygen, in this case, as electron acceptor. So you're using this pile, this reserve of energy, which is the organic carbon, to create energy, to release this solar energy that was trapped into the organic carbon. And to do that, as a byproduct, you are reducing oxygen into water and oxidizing organic matter into a CO2 back. This is for most of the metabolism on the Earth. The eukaryotes are doing photosynthesis or aerobic respiration. The microbial ecosystem are way more diverse. They can continue working without oxygen. This is just a summary to say that, okay, you're using this flow of electron for the organic matter that, like a battery will work for a toothbrush in this case here. It's just redox chemistry. Then you can have alternative way of doing photosynthesis with what we call anoxygenic photosynthesis. When using H2S as electron donor, okay, the source of electron is not water, but it's H2S, and producing elemental sulfur. We believe that this is a primitive photosynthetic metabolism that was before the oxygenic photosynthesis. This anoxygenic photosynthetic metabolism is taking place now in microbial mat or in environment that doesn't have any oxygen, but some input from the sun. You can find that in certain lakes or in certain marine environments. So you still have anoxygenic photosynthesis active today in environments without any oxygen. And of course, bacteria can do a lot more type of respiration. They can use a variety of electron acceptor instead of oxygen, nitrate, sulfate. Sulfate is the more dominant one. Iron can work also manganese in some specific case, a little bit more tricky with the manganese, but also no carbonate. So this is what we call anaerobic respiration. This is a way that organisms are using the energy stored in organic matter to create energy, to create ATP, but giving those electrons to another substance than oxygen at the end. And this is now finishing our carbon cycling in this case. So what I want you to grab as a take-home message here is all those different metabolisms are making the link between all the elements cycling. Here you have the biosphere, lithosphere, hydrosphere, atmosphere link, because in order to have the carbon cycling to work, you must have all those other elements cycling working, the redox cycling also. So all those different elements cycling are coupled to the main carbon cycling. And those are producing a lot of product, sorry for the redundancy, but those products can be organic carbon, can be gases, organic gases, CO2 can decay, change the CO2 in the atmosphere, but also can influence the lithosphere by precipitating minerals. In our case, calcium carbonate and limestone, but can also produce iron deposit, sulfur deposit, and all those different links between the lithosphere and the biosphere are seen in this carbon cycling. Again, all the cycles, oxygen, nitrogen, manganese, iron, sulfur, carbon, all the other cycles are coupled with the carbon cycling together. And understanding element cycling on this planet is understanding the ecosystem of the planet. When you want to understand an ecosystem, you need to understand how the organisms are getting their source of carbon, source of energy, and this leads to understanding of the element cycling. Or you can do the reverse. You can come from the element cycling point of view and look at what is possible and rebuild what was possible as a specific metabolism for life to develop. So this is the link between the different key element cycling on the planet.